Do you ever find yourself questioning reality? Have you ever considered that there could be more to this life? Today, we're taking a closer look at exactly how the world works, in the deepest and most fundamental ways. To start, we'll imagine the next dimension, the fifth dimension. Then, we're asking how could that affect life after death? Next, we'll spend some time on time, with a study that could change everything you thought you knew. And finally, we're wrapping it all up with the greatest question of all. Is anything really real? This is Unveiled, and today we're answering the extraordinary question, are there extra dimensions?
Do you need the big questions answered? Are you constantly curious? Then why not subscribe to Unveiled for more clips like this one, and ring the bell for more thought-provoking content.
The laws of physics, the seemingly definite guidelines humans have created to try and fathom the mysteries of the sprawling universe we live in. But they might not be what we think they are, and our existence could well be structured differently. We currently recognize at least partially 4 dimensions in the known universe, 3 spatial dimensions and 1 temporal. These are length, height, depth, and time. First, the easy bit. Imagine a straight line without any depth whatsoever. That's length. Add height and you turn it into a 2-dimensional square. Throw in width to create depth and you have a 3D object. Everything around us that we can see and comprehend is 3D. All the furniture in your house, every human you know, the distant planets and stars in the sky. The 4th dimension is where things get tricky, because despite knowing what time is, humans can't really perceive it. At least not in the same way a 4th dimensional being would. Our 3D cube would be extended yet again to form a tesseract or hypercube in a 4D space. Sure, we can create representations of what we think a 4D tesseract would look like, but if one suddenly showed up in real life, we wouldn't be able to fully understand it. If we were actually 4D creatures, then when we looked in the tesseract, we'd be able to see its timeline, its whole life beginning to end in front of you all at once. Were we to look at something slightly more interesting, another human being for example, we'd see and comprehend their entire existence from birth to death like a long photo reel. So if understanding the 4th dimension is already fairly difficult, what does that mean for the 5th, the existence of which is contested? Partly we need the concept of a 5th dimension in order to solve many of the problems we currently have with the movement of time. If time flows at a rate of 1 second for every 1 second, as per standard clocks, it wouldn't actually go anywhere at all, so we need a new spatial dimension in order to measure the flow of time. That's 5D. To go back to our tesseract, if you took it into the 5th dimension, you'd now be able to see all the different possibilities for the tesseract's life. Anything that has happened, will happen, or might happen, you'd see it all at once. With a human, you'd see every possibility for their life. Along the infinite paths that specific life could take, you'd see parallel worlds. With 5D capabilities, you'd be omniscient to some degree. You'd have full control over your own timelines, meaning you'd also have influence over all others, without the power to outright change them or alter history. Via 5D time travel, you could send information and messages backwards or forwards in time, communicating with future or past versions of yourself and indirectly with others. It would help us to understand our own futures, but also unravel some fundamental mysteries of the universe and accomplish an incomprehensible number of things. If we all lived in a 5th dimension, we'd be turning humanity's timeline as a whole into a circular ring of constant communication between every point in history. We'd be endlessly learning thanks to a collective effort across all generations. As such, a 5th dimension would shatter everything we think we know so far, writing off the theory of general relativity as our understanding of time completely changes. Einstein's idea that nothing could travel faster than the speed of light in a vacuum would also be challenged, with 5D beings whizzing backwards and forwards between the past, present, and future. And if we break into the 5th dimension, an until now almost incomprehensible realm, who's to say we wouldn't unlock more dimensions after that? String theory says the universe is the manifestation of one single object, a long string of existence made up of photons and electrons all vibrating in different ways. If it's true, it turns the universe into an even greater unified body, made up of as many as 10 different dimensions. M-theory is similar to string theory, but it goes one further by adding an 11th dimension. And then there's the bosonic string theory, which suggests there are as many as 26 dimensions out there. Make it to the 10th dimension in string theory or the 11th in M, and you are essentially a god. Not only can you see and visit any point in your particular timeline, as per 5D, but you basically are at every point in every timeline in the entire multiverse instantly. You understand the life of every one and thing that's ever existed in this universe, as well as you do every one and thing that's ever existed in every infinite variation of this universe. But let's not get ahead of ourselves. It's the 5th dimension we need to master first. Unlock this comparatively humble plane and we'd still be able to travel through many, many worlds, moving all across our own personal timelines and observing the infinite changes which make a difference in our many lives, big or small. In one world you got a different sandwich, in another JFK was never shot. In one lifetime you miss your bus, in another the Black Death never happened. If we occupied the 5th dimension, we'd be able to watch all of these different realities play out. It may currently be beyond the realm of human perception, but it'd grant us a higher understanding of our universe, ourselves, our planet, and time itself.
Where do you go when you die? Is there an afterlife? Will you remember this life? These are questions as old as humankind itself, but in recent years, we've discovered an all-new approach toward finding the answers. Death comes to us all, but is it really the end? Some philosophers, scientists, and academics are beginning to think that no, it isn't. One of the most prominent voices in the debate for and against some kind of continuation after you die is the British mathematician and cosmologist Bernard Carr. Alongside his more conventional physics background, including a reputation for black hole research, Carr is also interested in psychic phenomenon, the nature of consciousness, and of reality and death. In numerous papers, articles, and interviews, he has set out his ideas on how a multi-dimensional space could be the key element to understanding the lot. Perhaps the most famous quote attributed to Carr is, quote, "If you don't want God, you better have a multiverse," end quote. As a response to the so-called fine-tuning problem, it underpins so much of what he has to say. The suggestion being that for life, the universe, and everything to exist, there either has to be a God creating it so that it all works, or there has to be a multiverse to host all of the endless variations, including this one that works. In this way, we all exist in a multi-dimensional space, even if we're only aware of the 3-dimensional planes we can see. For Carr, though, that doesn't mean we're limited to only 3D-ness all the time. For example, he has spoken before about the nature of dreams, about how while they don't exist in our physical reality, they clearly do exist. In a way, we might say that while dreams aren't 3-dimensional, not exactly, they are something dimensional. So where and how do they happen? They also unfold alongside what we do understand as 3D physical reality. The two things are happening at the same time. So how is that explainable? Carr has also spoken at length more generally about the nature of consciousness in the mind. Of course, this has been an urgent problem for science for hundreds of years, and we still haven't properly solved it. But again, for Carr, the key to understanding consciousness could lie with unlocking the truth about our reality. That there are more, perhaps many more, hyperspatial dimensions. That is, dimensions beyond the height, width, and depth combined with time that we understand. When it comes to death, much of what we do know and have theorized starts with the testimonies of those who have had near-death experiences, or NDEs. And perhaps there are elements to NDEs that are very similar to how we would otherwise describe dreams. There are seeming physical impossibilities, out-of-body visions, a sense of heightened or distorted emotion. In papers and interviews, Bernard Carr frequently mentions a mysticism. It's not exactly a traditionally scientific term, but one interpretation of Carr's approach is that during an NDE, we perhaps enter or get very close to entering a different dimension, higher than what's physically possible for us now. And for those hoping for an afterlife, that could be extremely good news. But exactly how would it work? Carr himself never promises to know exactly what might happen. However, he has repeatedly highlighted that not everything is explainable through the laws and frameworks of physics as we currently have them, i.e. through general relativity and quantum mechanics. With things like NDEs, out-of-body experiences, and hallucinations, it can be as though physical reality breaks. For Carr, though, perhaps it isn't broken during these times, even if it is unknowable, and the existence of extra dimensions could be an inevitable truth in order to allow for these otherwise impossible phenomena. And therefore, readers of Carr might justifiably ask, if it's true of near-death moments, then why not of the moment of death as well? In 2021, Carr published a paper titled Making Space and Time for Consciousness in Physics. In it, he proposes that in order to reach a true theory of everything, we need a model that provides, quote, some form of unification of matter, mind, space, and time, end quote. He suggests that we require a new paradigm of physics to accommodate for consciousness. And he discusses the current distinction in scientific thought between physical time, i.e. as it plays out in the outer world, and mental time, i.e. as it happens in the inner world, in our consciousness through experience. The paper in itself is something of a culmination of all of Carr's thoughts and theories on the subject to date. What's seemingly key for the potential of life or something after death, however, is the possibility for what Carr calls, quote, psychophysical spacetime, proposed as an explanation for the relationship between physical and perceptual space. Carr writes, quote, the prime feature of our proposal is that perpetual space exists in its own right rather than just inside of our heads, end quote. Perpetual space is then a major independent and fundamental facet of reality as a whole. More broadly, for those who support Carr's model, the perceptual space is where anything that apparently isn't physically possible would be allowed to unfold. In the context of today's question, could it be where the afterlife is waiting? It's tied up with another key concept called the specious present, which, in short, relates to the time scale through which we experience reality. For humans, it's typically predictable enough to be unnoticeable in our everyday lives, but every so often it can speed up or slow down. For example, in a near-death experience, you might live your entire life in a second. Or if you're ill with a fever, it might feel as though reality moves faster or slower. Our perceptual space becomes significantly blurred during these times, but it's difficult to explain why using just the physics we have. Carr builds on this by suggesting, toward the end of his paper, that consciousness may not even be only an individual thing, that it might not be confined only to any one person, independent of everything else. He posits that after human consciousness, there could be a terrestrial or planet-wide level of consciousness, and then galactic, and then cosmic. In the paper, he doesn't reveal exactly how these levels might be linked, but he later describes them as a, quote, hierarchy of compactified extra dimensions. In his conclusion, Carr writes that his proposed model regards, quote, physical space and perpetual space as slices of a 5-dimensional space, with the 5th dimension being associated with mental time as distinct from physical time, end quote. Throughout the essay, he suggests that there could be more than 5 dimensions, though, that the 5th dimension is really only the minimum that would be required if we ever wanted to incorporate mental perceptual phenomenon into a unified theory of everything. Carr doesn't specifically mention life after death in the 2021 paper, although he has spoken about it at length in various past interviews and pieces. More broadly, though, his insistence in a 5th dimension at least, a plane to host mental time, implies that suddenly we aren't bound by just the 3D or 4D physicality of our bodies. And so when we die in the 3rd and 4th dimensions, could it be that we continue in the 5th? There's no doubt that the 3D matter that makes us is finite. It will decay, fail, and disappear. There's only so long that the human brain can last, despite its incredible complexity. But again, as Carr writes, the prime feature of this new proposal is that perceptual space exists in its own right, rather than just inside our heads. So when the brain is no more, could consciousness just move on? Has it always existed in a higher dimension? So is death actually not that important to it at all? What's your opinion on the wider implications of Carr's alternate model of reality? Do you believe that it is possible that some part of us will remain after our bodies have perished? Let us know in the comments. For now, these are intricate, at times speculative, but potentially radical ideas. Carr himself concedes that his extra-dimensional theories certainly don't represent mainstream physics, and that most physicists would be very skeptical. But nevertheless, if what he proposed is right, and if it could offer an explanation for not just known phenomenon like dreaming and NDEs, but also for what will ultimately happen at the end of our lives, then that's why there really could be another dimension after you die.
The concept of time for humans has always been somewhat tricky. It seemingly moves in one direction, but many natural laws appear to work backwards in time as well. Time seems to move at a constant rate, too, but we know that in the wider picture, it's actually completely subjective. and can change depending on how fast someone is traveling. We still don't fully understand time as a species then, but scientists may have just made another fascinating discovery about it. Because time is such a challenging concept to investigate, many aspects of it are arbitrary. Philosophers often have different concepts of time compared to scientists, and even our standard measurement system of time, made up of seconds, minutes, and hours, is simply how we choose to measure it. It's not as though it has to be that way. Breaking time down into intervals of 60 was first developed by the ancient Babylonians, who inherited their general number system from the Sumerians. Meanwhile, the length of our day is derived from how long our planet sees the sun in the sky, which means that a day as we know it is actually only really specific to Earth. As science has advanced, we've been able to define each unit of time more clearly. For example, the true scientific definition of a second is now how long it takes for a cesium atom to complete a set number of oscillations. This length of time is true time within our own structures for it. Zooming further out, we can view time as the fourth dimension of reality. Objects exist in 3 dimensions of space, but in order for them to experience change in any of those dimensions, time must pass. Space-time was a concept developed by Albert Einstein in the early 1900s to show that all of the dimensions, the 3 space plus time, can be collapsed into a single model that explains how they interact. Until today, that 4-dimensional 4D model has gone largely unchanged. So when physicists announced in July 2022 in the journal Nature that they've essentially created a new theoretical dimension of time, it's no surprise that people took notice. The study was held by a team at the Center for Computational Quantum Physics based in New York, although the experiments were staged in Colorado. And as it turns out, the discovery that was ultimately made wasn't exactly intentional. The team behind it were actually studying how to create a new phase of matter. But in the process, they ended up hosting a new dimension of time as well. At first, to create a new phase of matter, as was their intention, the team completed experiments in quantum mechanics. They wanted to create what's called a topological phase of matter, also known as quantum matter, which uses quantum entanglement patterns to build an all-new product. There's intricate science here, but what it comes down to is that different phases of matter are defined as such because they have what are known as different symmetries. When water is liquid, for example, the atoms within it are random and move around in space to fill empty spots. But when water freezes, it loses that freedom. Its symmetry has changed. The atoms within behave differently, and it has therefore become a new phase of matter. In essence, the breaking of the symmetry of atoms is what signals a change in the phase of matter for anything. But the team behind this latest study found themselves confronted with a further unexpected question. Because what if you broke the symmetry in time instead of in space? Led by the physicist Philip Dumitrescu, the team worked on a quantum computer with qubits in the initial attempts to create their new phase of matter. While regular computers use regular bits, zeros or ones, aka binary, quantum bits, or qubits, can allow something to be either a 1, a 0, or, because of quantum strangeness, both at the same time. This is important because it's this that allows quantum computers to be so much faster than traditional ones. And with the right know-how, it means that qubits could also, theoretically, be used to create that new topological phase of matter as they entangle with other qubits. In simplest terms, it's as though, in the quantum world, anything is possible, or at least nothing is guided by standard physics anymore. The problem is, however, quantum particles stop being quantum if they interact with the outside world in any way. And in this sense, they are extremely unstable and short-lived. To make the quantum properties last longer then, and to potentially create matter in this instance, the researchers wanted to stabilize the qubits by adding in time symmetry. Whereas spatial symmetry is just something that's repeated over and over in space, such as the atomic structure of a diamond, time symmetry is such that the individual qubits will always be the same at certain points in time. To accomplish this time symmetry then, the team used a regularly flashing laser. By having the laser pulse continuously at the same interval every time, an apparent dimension of time could be imposed onto the quantum objects, in hopes of stabilizing them. However, as complex as all that sounds, it didn't work. Despite the time symmetry added in, the qubits still barely lasted for more than a second. their quantum properties almost instantly failed, and no new phase of matter was achieved. But this is where the idea for adding in another extra time symmetry came into play. As next, the team used another additional laser, one that produced a different symmetry, to almost shore up the conditions for their hoped-for quantum matter. By doing so, they were arguably now imposing 2 dimensions of time onto the quantum particles. 2 lasers pulsing at different intervals in a bid, again, to stabilize the qubits into matter. The second laser was pulsed according to the Fibonacci sequence, which is a non-repeating pattern that actually already occurs throughout nature. It can be seen in everything from the arrangement of leaves on a flower to the pattern of pine cones and the shapes of some fruits. Ultimately, by adding in this second Fibonacci time symmetry, the researchers were able to stabilize their qubits for a short time and therefore create the new phase of matter that they had originally sought. The stabilization still only lasted for a few seconds, but nonetheless, for significantly longer than any other attempt made before. Most significantly of all, though, because of the additional time symmetry required to make the experiment work, it was as though the new phase of matter also only existed in a new dimension of time. Under ordinary conditions, it hadn't been possible, but by bending time to their will, the team were able to make it happen. So what's next? The study highlights a potential method for increasing quantum stability through dimensions of time. But what does that really translate to in the real non-quantum world? Well, for one, it's said that this breakthrough has the potential to revolutionize and fast-track our general efforts toward quantum computing and information storage. Anything to increase quantum stability or quantum coherence could lead to more viable and less error-prone quantum computing technologies. Currently, fully functioning quantum computers are still considered to be quite a way off, but for the team behind this study and for many watching on, the adding in of an extra time dimension could mark a vital first step along that path. Philip Dumitrescu, in an accompanying statement for the study, refers to the ongoing development of quantum computers as, quote, an open problem we're working on, end quote. It's tipped to become one of the most exciting and important technological advances in the near future, and this study may well have provided the key to unlock the door. As we step over the threshold into the quantum age, there are some predictions that quantum computing could quickly become a trillion-dollar industry. Such is the power and influence that it will hold over society. From chemical research to biological engineering, cybersecurity, encryption, and artificial intelligence, the scope for quantum tech is incredibly wide, even if the specifics are still somewhat ambiguous. The picture is clearing, though, and all it's taken is some major temporal remodeling to push the process forward. When you think about it, science in the 21st century is pretty incredible.
How far do you trust your own senses? Are you 100% certain that what you see is actually what exists? The human brain is the most complex thing on the planet, but also one of the least understood. And as we learn more about our neural center, human perception, and the nature of reality, there are some suggestions that what we see might not be what's really there. Philosophers have debated the nature of reality and perception for millennia, with one branch of modern philosophy, metaphysics, focusing on 2 distinct questions. What is there, and what is it like? The idea is that if we can ever conclusively answer both of those questions, only then will we have a definitive answer to what reality really is. The problem is that it's hard to do just that, to totally prove what's real. In ethology, the study of animal behavior, the word Unveiled is key, taken to mean the world as experienced by a particular organism. It's a crucial idea in philosophy and neurology too, relating to how we can never know if we all see the same things in the same ways. On a basic level, one person's interpretation of the color red may actually be green for you, but there's no way to test that such a difference exists. Every individual being's experience rests on how every unique brain constructs and understands the world around it. That's not to say that there isn't some method we can look to, though, and science does help us to measure and quantify reality. Simple experiments can serve to highlight the differences in how we see things, such as the rabbit-duck experiment, where subjects are shown an image that can be interpreted in 2 ways, as a rabbit or a duck, and they're almost always split on what they see first. Philosopher Ludwig Wittgenstein famously used the image to explain 2 different ways that he believed human beings see, which he called seeing that and seeing as. with seeing that being what you've unquestionably seen and seeing as being what you've interpreted despite multiple options. For cognitive psychologist Donald Huffman, though, the significance is greater still. Hoffman proposes that we never see, or in any way experience, reality as it actually is, but rather as a set of delusions catered to ourselves which help us to survive. In this way, we're not seeing, or even feeling, smelling, or hearing what's objectively real, more a series of shortcuts specifically created by our brains in order to give us the best chance of understanding and processing the information that's put before us. Since reality is so hard to measure, then, can we ever know the truth? The murky world of quantum physics provides arguably the best scientific platform from which to pick it apart. Quantum physics is the study of the world at its smallest points, where the laws of nature break down and stop making any kind of sense. John Wheeler's delayed choice experiment, first proposed in the 1970s, provides one of our finest examples of how reality can change simply by viewing it. The experiment begins with the understanding that an atom of light can act as a wave or as a particle, but at which point does it choose which form to take? To find out, researchers place a crossroads in the path of an atom of light, knowing that if it were a wave, it could travel down both paths, but if it were a particle, it would have to choose one direction or the other. The paths are then randomly reconnected, with some merging back together again and others not. It's a complicated process, but the crucial bit is that the experiment finds that an atom of light's form is only determined once its destination, a merged or non-merged pathway, has been decided. The future dictates its past, meaning that the atom wasn't in any form until it was measured. According to Andrew Truscott, one scientist to have conducted the test, at the quantum level, reality does not exist if you are not looking at it. It's heavy science, but it also forces us to fundamentally rethink how we experience life. And there have been plenty of theories put forward as to why nature acts in this way. One idea is that we live in a simulation, a proposal gaining some traction in the scientific community, with figures like Elon Musk and Neil deGrasse Tyson lending their support to it. For advocates, the atoms that make up our world could mirror the pixels used to build video games, while our genetic code is, well, just that, a code not unlike the data streams which pass through other digital technologies. In fact, in 2017, a team from the University of Washington showed that our actual DNA can even be infected with computer viruses, suggesting that both our makeup can be programmed and also that that program could be at risk of getting hacked. For some, another key indicator is how immersive and lifelike our own simulations are becoming. The idea being that if video games are now so technologically advanced that they could soon be indistinguishable from reality, then what's stopping us from already featuring in a sim that's tantamount to real life? While it's a much more hypothetical answer to today's question, most games don't load their entire maps all of the time, but rather only the areas that your character enters into. Match the same process to our own lives, and perhaps nothing exists outside of that which you're immediately experiencing. Here's where we begin to cross into another field of philosophy called solipsism, which is the idea that your own mind is the only thing in the world we can know to exist. René Descartes famously said, "I think, therefore I am." To him, his thinking was the one part of reality that he could be absolutely sure was real. Everything else in a person's life might simply be imagination. In this way, people, places, and things only come into play when you hear, see, or feel them through your senses. Before then, they're not there. Again, because everyone has a unique point of view, it's another mind-bending theory that's ultimately impossible to prove or disprove. We can, in a manner of speaking, disprove those senses, however, because in some ways, your senses don't actually exist. Sights, smells, and sounds aren't truly real, they're just the product of your brain working out what to alert you to, and how specifically to convey that information. Your brain has never seen or heard the outside world because it's encased within your skull, so it uses various tools to detect the world around it, like eyes and ears, but those tools could well be faulty or deceptive. At its heart, our reality is more the result of electrical signals that course through our brains. Our experience is whatever our neurons tell us it is, and the world itself follows suit, but by swapping brain activity for basic atoms. Now, cars aren't actually cars, for example. They're just a bunch of different atoms sorted in a particular way. Yet we see a car because our brain forms that image. So from some perspectives, we can say that a car doesn't exist until we see it, because it's only atoms until we perceive it as a car, until we assume Ludwig Wittgenstein's seeing as mode. There's no need for crisis just yet, though, because none of this changes how or why we live our lives as we do. If we're part of a simulation, then what difference does it really make? If atoms beyond our perception are capable of changing as soon as we glance away, then the human experience continues as it has always done regardless. Every time you look at something, it's going to be there. But still, it's an idea which pushes us into a total change of perspective. Perhaps the only things that exist right now are whatever it is we're currently experiencing. Perhaps even when we blink, everything else disappears, or there's nothing behind you until you turn to look at it. Really, it doesn't matter. Life goes on, and we should all try to enjoy the exciting uncertainty of it all.
So what's your verdict? How many extra dimensions do you believe there are? Or are you satisfied with just the 3 space plus time that we know and have right now? As always, air your views in the comments. For now, this is one field of theoretical science that truly asks us to reimagine the world. Because actually, 4D might not be enough to properly explain everything there is. And that is a pretty major realization. Are there extra dimensions? The jury's still out, and the research is still ongoing. But if we ever did go beyond length, height, depth, and time, then it surely would change everything forever.
What do you think? Is there anything we missed? Let us know in the comments. Check out these other clips from Unveiled, and make sure you subscribe and ring the bell for our latest content.